Now,
Cool. Yeah, so my name is Dinesh and I am an engineering manager at SumUp at the moment. And previous to SumUp, I was leading the developer experience team for Android at a Southeast Asian startup called Gojek. And before that, I was working for a travel company called Redbus. So I've been in Android for around 11 years, right from gingerbread in my college days. So, yep, so that's a little bit about me. And today let's talk about Perfetto and how can we use Perfetto to find out what's wrong with the recycler views. Right. So let me give an introduction about the user interface thread and what it means. So UI thread is to me the most less understood phenomenon of Android, and it is the most important phenomenon of Android. And every frame on the phone that you see has to be rendered within is a lot of work because you need to parse the XML files, layout them, measure them, and draw them all together in 16 milliseconds. Hence, let us not make the user interface thread do a lot of work, and let's keep this guy as less occupied as possible. And now let's talk about a recycler view and what causes recycler views to be janky. And the key word over here is skipped frames. Now let's assume a recycler view with just 5 elements on the screen. And let's assume that each item, the yellow item that you see, takes 5 milliseconds to render. Now in total, we have 5 elements, which makes us 25 milliseconds. So in total, this screen would take 25 milliseconds to render. But the time allowed for one frame to be rendered is just 60 milliseconds, which means that we are overshooting by 8 milliseconds, which means that we would be dropping frames and the Android system will not be able to draw frames, hence it will skip frames. When frames are skipped, it gives the user um, a feeling of the UI user interface becoming very janky or slowness in the UI or get jagged, however we want to pronounce it. But the user experience is not going to be good. And now let's see how we can deal with this, right? So let's say that you join a new startup or you join a company where you inherit a large code base and the recycler view over there is laggy. And how can we go about debugging what's wrong with the recycler view? Now let me pause this presentation for a second and let me jump right into the code. So what I have here is a simple application which displays the countries and the provinces in different countries. So let me launch it. All right, pretty straightforward. Right? You have Afghanistan and you have all the states inside Afghanistan, Albania, Algeria, and you can keep scrolling from bottom to top to bottom, and you can see all the states, right? And yeah, you can see that as I scroll, it's not very smooth. Right? It gives a janky feeling when I scroll. Now let's visualize how bad this jank is. Right? For that, we have this option in the developer settings. So we can go to the settings option in our phone, and we can go to the developer options. Now there is an option called HWUI. If you can scroll through, unfortunately, this does not have the search option. Hence, I need to scroll to the very end. Yeah. Now you can see an option called Profile HWUI Rendering. So if you switch this on, and then you can select an option called On Screen as Bars. Now let's come to the application and run it once again, and let's see what happens. All right, now as I scroll, you can notice that there are too many vertical bars over there, and the height of these bars are insanely high. And you can notice a red color horizontal line in the bottom of the screen. Right? So this red color horizontal line indicates the 16 millisecond which we were talking about, right? And our aim must be to have all the vertical bars as close or as less than the red line as possible, right? Now, whenever you see that a line goes above the red line, so you can see these guys, they are very tall, which means that the system is spending too much time rendering, right? And you can see that as I scroll through, right, you can see that the vertical lines being drawn are huge, right? Which means that this is not a good state to be. And so this is the first point of investigation where we can know, okay, this recycler view is not good because as I scroll through the recycler view, there the vertical bars are just too high, right? Now let's jump into the code and see how we can let's try to map these vertical bars to the code that is actually causing these high vertical bars, right? So there are two ways that we can do it. One is just through visual inspection, we can see if we have anything that's happening in the recycler view. So this is a simple recycler. We have the on create view holder, on bind view holder, and we have a view holder, an item view holder, which basically does the recycling, right? And now this is a very simple code to look through, right? But when you see production grade codes, it's very difficult to understand right at the point where you see the code. Hence, what we can do is let's try to measure out what's happening. So going back to the basics of the recycler view, the onBind view holder is the method that's going to be called on every item on the recycler view, right? Which means that let's try to measure how much time this onBind view holder takes. And this can give us an indication of how much time the system is spending to execute this simple function, right? And how can we measure it, right? So we can use simple system.out.println with a start time, end time, do the difference, and then print it out on lockhead. Or there's a much more better way of doing it. That's where there's something called the traces API come into picture, right? So whichever method you want to profile, you can just say trace dot begin section and with an identifier of on bend view hole, you can have whatever you want, and in a few minutes you will see what this guy is all about, and then you can stop the trace whenever you want. Right? So right now what we are doing is we are just measuring the time it takes for the system to execute this function, which is on bind view holder. Right, cool. Now that I have put these traces, so now I have a trace start and then trace end. So now we should have a way to capture how much time this takes. So let's build this app and then run again. All right. So now the app has started to build, and the APK that we install would have the traces put inside them. Hopefully, we'll be able to measure it. As usual, Gradle is taking a bit of time. So I'm used to using command line because I'm an old schooler and I don't have the habit of pressing the play button. Apologies for that. All right, cool. So now the app is installed. Let's go ahead and disable the GPU inspection and then try to record the trace. So I'm going ahead to the settings. Cool. I'm turning this off. Now we need to record the trace. Right? So the way that we can do this is there's an option called system trace. If you search for uh, system trace inside the developer options, yeah. So you can see that there is a. Oh wait, let me just go into developer options and show you that. Cool. And scroll. Yeah, so now you can see that there's an option called system trace. And so it records the system activity and analyze it later to improve the performance. Now let's switch it on. And so I'm switching on the quick setting style so that it becomes available right over here. Right, so you can see the record trace option. So let me start recording the trace. And now let me open the app. Play around with the app for as long as I want. And now let me stop recording the trace. Perfect. Now you can see that the trace is saved, right? Now let's pull the trace from the phone to my desktop so that we can analyze it. So this guy will be present inside. It will be present mostly inside data/local/traces, but it differs from phone to phone. Cool. So now we have one file pulled. Perfect. Now we have the traces pulled. Let's see if the trace is available. Perfect. Now we have a Perfetto trace, which is recorded at 22:53. Yeah, that's my time. Awesome. 20. Perfect. Now let's try to open this file and then see what's happening inside this file, right? So Systrace was a pain. Like Systrace, you need to have this Systrace installed in your PC to look into it, and it's not searchable. It's a lot of pain. But there's a new and improved version of Systrace called Perfetto. So all you need to do is let's go inside perfetto.dev. And this is an Android tool, and you have an option called Trace Viewer. Now let's open the trace file that we just recorded. Cool. Perfect. Yeah, let it open. Now there's a lot of information to consume, right? So, but let's just concentrate on what's happening inside our application, which is com.code8.perfetto debugging, right? And even here, you can see that there's just too much data that's available over here. Let's not bother about all these things. And that's the reason why we have this identifier that we set. So let's just copy this identifier and then search this guy. Perfect. So now what you are seeing over here is this guy is the UI thread that we are looking into. And what this is giving us is that this tool is giving us a very detailed information about what is the method and how much does a method take to execute and on which thread is this guy taking to execute, right? So you can see that the whole recycler view trace is being captured over here, right? So you can see the traversal, the layout, the draw faces, right? So let's concentrate on the on-bind view holder and the trace that we just put into, right? And as you can see, This guy is taking 722 milliseconds. That's just crazy. Right? So we are left with 16 milliseconds to render something, and then here we have at least 500, at least 50 times more. And 722 milliseconds is nowhere near to the 16 millisecond mark. Let's also inspect the others, and now we have here 111 milliseconds, which also is bad. And the other ones, 300 milliseconds, also pretty bad. 48 millisecond, also pretty bad. Right? So now we can see that the on-bind view holder of this recycler view takes a hell lot of time. Right? Now we know who the culprit is. We know that okay, on-bind view holder is taking a lot of time. Let's try to optimize it. Now with this information in hand, right? So now we have figured out that the on-bind view holder is the troublemaker for us. Now let's go back to the code and then do a visual inspection, then see what's wrong with this. Right? So this, when you don't know what's happening on the recycler view, tracing the recycler view can help you identify in which part of the recycler view is the problem. Right? Now let's go back to the code and see what's happening. All right, so this is the on-bind view holder, which is taking 48 milliseconds to 700 milliseconds. And right away, we can see that there is an iteration that's going on inside the on-bind view holder. And this happens to be happening in something called a chip holder. And then inside the chip holder, you're adding a lot of views, right? So this could be the chip holder, and then we are adding a lot of chips into this. So this is a horizontally scrollable component, and we are adding views into the horizontally scrollable component on every on-bind view holder. And then now let's go into the um, layout file and then see what this guy actually is. All right. So now we have an indicator over here. It's a horizontally scrollable view, and we have a linear layout, horizontally oriented, and you're adding chips inside this horizontal linear layout. Can we do better than this? This is a horizontal uh, scroll view, which means that if you add 10 items, all the 10 items are going to be rendered. If you add 20 items, all these 20 items are going to be rendered. So let's see what happens if we replace this horizontal scroll view with a recycler view. Right. So let's take this guy off. Let's comment this whole horizontal scroll view, and let's just replace it with a recycler view, and let's add these chips to the recycler view. Obviously, recycler view is not going to render all the 50 or 100 components you have. It's going to render only what's on the screen, which means that we can save a lot of time from rendering. And let's see how the performance looks like in this case. Yeah, let's go to the adapter and let's make a few changes. Yeah, I'm going to comment this and then enable the recycler view. And obviously, we need uh, an adapter for the recycler view. So let's just enable this chip adapter. And this chip adapter is a pretty simple thing, right? So I have a chip. Yeah, I just have a single chip which I'm inflating, right? So now, based on our intuition, we would at least be saving 50% of our time. And so if there are more than 5 items on the screen, we'll be rendering only 3. And so let's see how this performs. Let's still have the traces with us. Let's build the application. Let's inspect it using the GPU rendering trace, GPU rendering tool, and then let's go back to Perfetto and see how it's happening. Let's build the app. While it builds, let me go ahead and enable the HWUI rendering option. Nice. So I have enabled this and we have our new optimized app. Now let me try scrolling rapidly over here as well. Oh, it's it over, I guess. All right, cool. Not as bad as the first one. Right. You can see still some, you can still see some jank, but not as bad as the first one. And so now you can see that it's pretty much smooth, right? You can see all the lines more or less near the red horizontal line. Right? Now let's go back to the traces. Let's try to record a trace and then see how much have we reduced. Right. So I'm going ahead and then disabling the HWY rendering options, and let's record a trace. Turning it off. Let me kill the app. Let me start recording the trace. Open the app. Play around with the app. I'm stopping the trace. Trace is saved. Let's pull this guy into the machine. All right, cool. So let's go ahead into Perfetto. So open the trace file, which was recorded at 2304. Yeah, this is the guy. All right, there we go. So let's search for the same trace and let's see what's happening. Yay. So we have the first one, which has reduced to 6 milliseconds. Right? So earlier we had 48 to 700 milliseconds. Now we have a 6 millisecond, which is very positive. Let's see the other one, which is it's 302 microseconds. Let's go to the next one, 812 microseconds, 391 microseconds. Yeah, we can see that there is a drastic improvement in times, and we have this validated through Perfetto as well. Right? Now let's see if we have any other improvements that we can do to make this guy even much more faster. Right? And you can see that this chip might be an overkill over here because we have all the clicks over here and the animations over here. Let's widely see what happens if we replace the chip with a simple text view with a simple background. Right. So all we need to do is we need to go to the chip adapter and then introduce a text view instead of a chip. And in the layout, let's replace the chip with a text view, which I have already coded for you with a simple background. Now we have come from 700 milliseconds or to 48 to 700 milliseconds to 6 milliseconds. Let's see if introducing a text view makes this even better. Fingers crossed. Let's try to run this app again. All right, cool. Let's go ahead and enable the HWUI. On screen as parse. Wow, what just happened? Much more smooth, much more scrollable. Right, it just feels like butter running, hot knife running through butter. Let's see what the Perfetto trace tells to us. Let's disable this guy. I mean, I'm just disabling the HWUI option because I don't want this to introduce any overhead to the uh, tracing overhead to measuring the traces. So let me start the trace again. Let's open the app. Scroll, 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 scroll as long as you like. All right. Let's stop capturing. Traces is saved. Let's pull the traces. ADB pull. There you go. All right. We have the traces. Let's go to Perfetto. Open the trace file again. This guy's the latest 2308. Yeah, cool. Cool, it's loaded. Let's go into our investigation subject, which is com.codei.perfetto, and we are interested in this trace. Let's see what happens. All right, so you don't even see this. It might be a case of um, a very negligible amount of negligible amount of time which this guy takes. That could be one reason that it's not recorded. Let's try one more time to see what's. Let's see one more time and let's see if we can um, capture this trace. Cool. Let's start recording. Let me start scrolling. Let me start scrolling. Scroll. Stop. And let me stop recording. Yep, trace saved. Let's pull this guy. All right, let's go ahead and open this trace file. Last one. Yeah, so we don't see any of those that trace, and it could be a matter of a bug with Perfetto, or it's just so negligible that we have optimized so much. But hey, but you get the idea, right? So you can use Perfetto to see what's happening to your recycler view. Cool. Yeah. So coming back to the presentation. Cool. So there are a few common sources of slow rendering times for recycler view, which is these are some of the most common things that I have faced in my career. So I think it'd be a good thing to share over here, which is um, parsing data objects inside the on-bind view holder. Right? If we use any if-else condition, if you ever see any if-else condition or a for loop inside the on-bind view holder, then that's a red flag. So you may need to move it to a different thread before the data comes to the on-bind view holder. The same thing, like writing business logic inside on-bind view holder. Even things like showing and hiding views or changing colors can be avoided inside recycler view as much as possible. And then having a very nested hierarchy for the recycler view holders, that can be another source of jank, because the more complex the view, the more time it's going to take the Android system to inflate the view. And yeah, and I've seen a lot of scenarios where the views are very generic, and then developers showing and hiding views based on business logic. So this can be avoided as much as possible. Rather, we can have a lot of different view types, and that would be good as well. Yeah, so what are the alternatives, right? So we know that recycler view performs bad in certain situations where you have too many view types to be rendered on the screen, right? But you have alternatives, right? Epoxy and litho are good alternatives which perform good when you have too many different view types to be rendered on your screen. Especially litho, it has very fine-grained optimizations. Litho from Facebook has very fine-grained optimization. It also has a good declarative way of coding recycler views as well. And the one cool thing about litho is recycler view caches items based on view types, right? So if you have 4 view types in your recycler view, there will be there will be 4 items on your cache. And litho goes very deep, so it caches on a view level, right? It just forgets about view types, and it goes into depth, and it says that, okay, if there are 4 text views, I just need to cache one text view, and then it looks into image views and then say, okay, there's an image view, and so I'll just cache an image view, and then I'll forget about all the view types that are out there. So it's very fine grained, and it's pretty good as well. So yeah, so that's about it. So I think you guys would have had a fair bit of idea about how to get started with Perfetto, and yeah, I'd be happy to help if you guys need more help as well.
Thank you very much, Dinesh. So, any questions from the audience? Like I said, you can also use Slido, which I will show in a second.
From my side, I just wanted to say thank you for this super insightful presentation. I also heard that some other types of screens are not only 60 Hertz, but sometimes 90 or 120. So we should probably even aim to optimize for maybe like 4 or 5 seconds.
Yeah. So yeah, I mean, I'm not aware of this, but in general, the Android rendering time is 16 millisecond. I mean, I've not heard about hertz. So yeah, I just try to stick to the 16 millisecond and try to keep the rendering time of on-bind view holder to less than 3 millisecond as possible, so that we can accommodate at least 4 items on the screen based on the use cases.
And those alternative frameworks, you mentioned using Lito, right?
Yeah.
Could you tell us a bit more about your experience with that?
Yeah, so I have experimented with Litho. So Litho goes the only problem with Litho is that it includes a native library. So your size might increase a bit. So it uses an SO file which you need to include using the SO loader for Android. So it may increase the size, but for highly complex views, it works really good. And uh, especially for social media platforms like Facebook or Twitter or Instagram, where you have rich content to be displayed on the screen, Litho works very good, because the key point about Litho is that it does not cache at a view type level, rather it caches at a view level. And so you can think about this. You have two view types, and then let's say that the two view types have text views only inside them, right? So it's just a grouping of text views. And so why do you cache two view types? You can go one step deeper, and then you can cache only views. So yeah, there are some interesting talks on the Facebook engineering page about Litho and how they went about creating Litho. It's a very interesting talk that you can definitely check out. But yeah, so in my experience, Litho has worked out really well for highly complex screens which require scroll. Yeah, but yeah, there's a small overhead of app size, which I guess it's okay given the use cases.
Awesome, thanks. And we have also some built-in tools in Android Studio. Did you have some experience with that?
Yeah, so I have used the CPU profiler and the network profiler and the memory profiler. So, but this was Perfetto gave me a very good insight into specific things, right? So, but you can obviously see where in your use case are you hitting peak memory performance, right? So let's say that you have a product flow, a product checkout flow, where you select an item, then you add it to your cart, and then you go to the payment, and then you check out. If you want to see in which part of this funnel does your app peak in memory, in those cases, definitely the built-in tools like memory profile definitely helps you, because you can visualize it in real time, right? So but when you have to go very fine grained, and when you need to extract data out of specific use cases, I've seen that Perfetto and Systrace gives me much more information. It's just the information that I need most, right? But in Android Studio, you have a lot of information which is a bit difficult to consume, but this guy gives me the information that I'm looking for. But yeah, either ways, those memory profiler and network profiler and the CPU profiler are great as well.
And on the website of Perfetto, there was something about leak canary, if I saw correctly, or
I'm not sure about that. I've never I've used it leak canary far very early, just to find out memory leaks. So that's about how I used leak canary. I'm not aware of leak canary in the context of Perfetto.
I'm just on this first round graph on their pie graph chart on their, but yeah, but still, thanks.
Any other questions from the audience? So a question to the audience from my side: did you anytime had to do performance analysis with Perfetto or Systrace until now?
Yeah, so a lot. So I was working in applications which were working in places of low data and low bandwidth. right? And the devices, the phones were not that great, right? Like it's a lower middle class section of people who are using the application. So we had to cater to a wide variety of audience, right? And we need to give them a superior experience as well. And so, and also, it was mostly drivers who are using the applications for delivering food. So for an application called Go Food, which is in Indonesia, so drivers were using. So you cannot expect drivers to buy expensive phones. So they had memory which was like 4 GB of RAM or even 1 GB of RAM. And so in those cases, very rich text content will gives them a bad experience. So if we may think that okay, rich text content and rich information gives good user experience, but in terms of in their world, it's like bad. And so
Mhm.
that was one time when I had to use Perfetto, use Systrace, but because Perfetto is just 1 year, just an infant baby right now. So back then I had to use Systrace to see why the performance is so slow. Because reading through the code, it was heaps and heaps of code, and it did not lead me anywhere. And my first intuition was to put system.out.println uh, and system.get current time in milliseconds. Again, use system.get current time in milliseconds, do the difference, and then print it out. But what I was missing was in which thread was this guy operating. So in which thread was the time difference calculated. So Systrace really helped me to understand, okay, I'm doing something on the UI thread and this is exactly the time that I'm doing, right? And when you optimize it, and so you need to test it on different devices. So I even wrote an automation script where you just put this into 5 phones, you plug 5 phones into your PC and then launch this, capture the trace, pull this, and then draw the diagram and then see what's happening. So
I think that's definitely true. From my experience from the last, let me lie now, 11 years in Android development, I think most of the people in Europe doesn't do that because most of the people have more actual devices, so they are not really in that position, like you said, where they have to run deep into optimizations like that with this trace and also with all this memory dump also and all this stuff. So we have quite the luxury that we didn't have to dig deep into these stuff. I think I just did it once when I was at a company, and that was really where we had a big issue there. But for the product owners or the product managers, that wasn't a big issue because it's working. It's just a bit slow.
exactly. So, but yeah, so the app that I was working on had like 600,000 to um, 600,000 to 3 million active users on a daily basis. So it was very large scale, and which means that the performance impact was and so there was a lot of money. So and they may switch to competitors. So it has to be done. So we had a separate team formed for just concentrating on performance, and their KPIs were rendering time. So rendering time was their KPI, and memory usage was their KPI. So they were just assigned to do one thing, which was make the app performant. And this is all that you need to measure. Measure the rendering times, measure the frame rate, measure the ANRs. That was all those was there. So yeah, it was a good experience. Yeah.
I guess.
And for me, that all sounds like, for example, for UI tests, working with
Now we have the Android performance like Android X dot performance library, which you can use to collect real-time matrices while you're running espresso test cases. Right? And you can export it to a JSON, and then you can send it to any visualization platform that you have in-house, maybe a simple Elasticsearch and Kibana, and then you can visualize it. And the beautiful thing with Firebase is that it can give you, if you are using Firebase performance monitoring, and if you enable it in production, it can give you these matrices of frame rate as well. So yeah, it's pretty important for large scale apps. Okay, so the Android X performance library I guess it's Android X benchmark. I guess Android X benchmark, Android X performance. I don't remember the exact name, but it can actually mine you all these.
Okay. If there's no public question anymore, give you another 3 to 5 seconds. I will just stop the recording to give you the stage if you want to ask questions without any recording. 1, 2. That's in the chat. Thanks, Oya. Like I said, Dinesh, thank you very much for your presentation. It was really awesome to have you here to give us some insights on some stuff that we rarely do here, especially me. So I will stop the recording.